What is the truth about cold fusion? Imagine a world where energy is cheap, clean, and almost limitless. That's what many hoped cold fusion could deliver. But what is cold fusion really, and is it a real science or just a myth? Let's find out. Cold fusion is the idea that nuclear fusion, the process that powers the sun and hydrogen bombs, could happen at or near room temperature. Normally, fusion requires extremely high temperatures, millions of degrees, to force atomic nuclei to combine. Cold fusion claims to do this at much lower temperatures, making it a potential game-changer for energy. The story starts in 1989, when electrochemists Martin Fleischmann and Stanley Pons announced they had achieved cold fusion. They used palladium electrodes and heavy water, which is water with deuterium, a hydrogen isotope. They passed an electric current through this setup and claimed to produce excess heat that couldn't be explained by chemistry alone. They suggested this heat was evidence of fusion happening at low temperatures. The idea was exciting because it promised a cheap, clean energy source. But the scientific community was skeptical from the start. Many researchers tried to replicate their experiments but failed. They couldn't produce the same excess heat, and crucially, they didn't find the expected nuclear byproducts like neutrons or tritium, which are signs of fusion. Without these signs, most scientists believe the original results were due to experimental errors or contamination. The U.S. Department of Energy reviewed the claims twice, once in 1989 and again in 2004. Both times, they found no convincing evidence that cold fusion was real or reliable. Despite this, a small group of researchers kept studying related phenomena, calling it low-energy nuclear reactions or condensed matter nuclear science. Some recent experiments have shown strange results, but these are not accepted by mainstream science. The idea isn't new. Back in the 1920s, some Austrian scientists claimed to produce helium when working with palladium and hydrogen, which would mean fusion. But they later retracted their claims, suspecting contamination. Early attempts to patent cold fusion devices also failed because the mechanisms behind it were never clearly explained. From a weird science point of view, cold fusion is a fascinating story of hope, mystery, and controversy. It involved unusual experiments, unexpected heat measurements, and persistent fringe interest. It shows how science sometimes encounters strange phenomena that challenge what we think we know, even if they don't turn out to be real. In practical terms, cold fusion has not provided any usable energy. The initial dream was to create a cheap, safe, and unlimited power source. That dream remains unfulfilled. Still, the story continues to inspire curiosity about whether unknown nuclear processes could happen under unusual conditions. So, the truth about cold fusion is that it remains unproven and controversial. The original claims have not been reliably duplicated, and most scientists agree it's not a practical energy source right now. But its strange history and ongoing fringe research keep it a notable chapter in the story of experimental science and scientific debates.